In this video, we are going to sketch the graphs of some circles and also write equations in standard form of circles. Getting started, we're going to analyze the standard form equation for number 1. We want to identify the center and the radius, and then let's see how we can create a graph from this information. First, let's determine the coordinates of the center. Positive 2 and negative 5 translates 2 units to the right and 5 units down. What is the radius? The radius squared is 9. If the radius squared is 9, that makes our radius equal to 3 units. So let's first start by placing the point 2 to the right and 5 units down. This is our center. All points on the circle have to be 3 units away. The immediate first 4 points we're going to graph are north, south, west, and east. Let's go 3 units up. Let's go 3 units down. 3 units to the left of the center, and 3 units to the right of the center. I really would like to make my circle as smooth as possible. I don't yet trust myself to sketch a circle using only these 4 points. Perhaps I can find an extra point that I can then adjust and create a smoother circle out of. The simplest x-coordinate for me to plug into this formula. Now I don't want to plug in anything that's beyond -1 or beyond that looks like positive 5, because then it will be outside the circle. We'll get an answer that's not defined. Maybe it's 0. What would happen if we plug in 0? 0 take away 2 is -2. -2 squared plus the quantity y plus 5 squared equals 9. So this is when x equals 0. So we plugged in 0. Now we're going to evaluate. The left side has a constant of 4. The right side has a constant of 9. Let's subtract 4 from both sides. Now we have a statement. The quantity y plus 5 squared equals positive 5. Square root both sides. And since this is a coordinate and not a length, we're going to use the plus and the minus sign. Finally, let's subtract 5 from both sides. -5 plus or minus the square root of 5. Let me use my calculator and identify what the value of the square root of 5 is. Square root of 5 is approximately 2.24 units. So if I have an x-coordinate of 0, then I'm going to take my y-coordinate and plot looks like 2 points. What is -5 plus this answer? -5 plus this answer is -2.75. What is -5 minus that answer? -5 minus the square root of 5 is -7 and -7.24 approximately. -5, -6, -7.24. What we're going to use is proximity to plot some extra points around the circle. Proximity just means from one of these extreme left points or right points or extreme up points or extreme down points, I need to go 1 unit away, 1, 2, and 2/4. So one box to the right, 2.24. So 2.24 in each direction. So if I go 1 box down from this extreme point, 2.24. So there's 2 points right here, away from the bottommost point. Let's go 2. So let's go up 1. Let's go 1, 2.24. Now these points are very close together, but at least it'll give me a good sense of where I should end up. Go down. Let's go 2.24 this direction. Let's go left. Let's go 2.24 in that direction. Let's go left. Let's go 2.24 in this direction. Let's go up and 2.24 in that direction. This gives me a little bit of a better sense of where these points would be located on my circle. Then I can sketch my circle. Of course, if I did extra points, my circle would be a lot nicer. And my job is to be precise with how I graph my circle. I don't want just 4 points connected. I'd rather you see and you take the time to even do 1 extra point, because from that 1 extra point, what we are able to do is find points with proximity where they should belong. If you don't like it, if you don't like the way your circle looks, then what you could do is you can just trace around a little bit. You can smooth it out a little bit nicer than I did, but that's actually not too bad. Now we'll see in the next exercise why this one is a lot different than the first one. It's a lot different because this formula is not in standard form yet. I'm going to move the x term not across the equal sign, but I'm going to place it next to the x squared term. And I'm about to proceed to complete a square. The y term is squared, and I don't have any other y's, so I'm only completing one square this time. Divide the leading, not the leading coefficient, divide your linear coefficient, also begins with an L. Divide your linear coefficient by 2 squared and add this number to both sides. -3 squared makes 9. Let's add 9 to both sides. The left-hand side contains a binomial squared. Now this is in standard form. This is very unique, and I'll show you why. The x-coordinate of the center is +3. The y-coordinate of its center did not translate up or down, so it stays at 0. The radius of this circle would be 5 units because the radius squared is 25. Here's what's unique about this. We know about a special, it's not a special right triangle based on its angles, but we know a unique right triangle that has side lengths of 3 and 4 and a hypotenuse of 5. This is the 3, 4, 5 right triangle. It's not a special triangle, but it is a Pythagorean triple. We know that if I need to be 5 points away from a central point, I can go 3 in one direction, horizontally or vertically, and then 4 in the other direction, vertically and then horizontally. I'll show you what that means. Start by plugging the point 3, 0. This is your center. And let's go north, south, west, and east 5 units. North 5 units, south 5 units, west, and east. Now I don't want to connect these. This doesn't give me a great sense of what the shape is, but our Pythagorean triple, this will help us. If I go 3 boxes right and 4 boxes up, this would form a right triangle with 2 legs of 3 and 4 and a hypotenuse of 5, meaning this point is 5 units away from your center. Instead of going 3 to the right and 4 up, I can go 4 to the right and 3 up, 4 to the left and 3 down, 3, I think I said left, I think I meant to say right, 3 to the right and 4 down, 3 to the left and 4 up, 4 to the left and 3 up, 4 to the left and 3 down, 3 to the left and 4 units down. Just by knowing a Pythagorean triple, now I have an outline and a good sense of where I can sketch my triangle, my circle. Do as best as you can. Sometimes it works better than others. All of these points that I'm tracing out are 5 units away from the center because the radius of the circle is 5 units. With very little effort, we were able to make a very nice picture of our circle. At the very bottom, there are 2 questions which aren't really related to graphing, but we want to provide an equation for a circle given this given information. So the first one will be easier. The second one may take a little bit more work. We have our standard form equation. Our center will be at h and k, and our radius would be 3. So here's what we're going to do. X plus 3 inside of parentheses squared plus y minus 2 inside of parentheses squared equals 3 squared, which makes 9. This equation is standard form. We've identified, I'm double checking the fact to verify my center is correct, and the radius squared is 9. This one is completed and completely done, nothing more to do. If you multiply these out, you would make some other different type of equation, but the directions say standard form equation. This is standard form. In our last exercise, we do want the center to be at 6 and positive 1. So if both coordinates of the center are positive, we'll use minuses. And our radius needs to be squared. Now what is the radius? This point is on the circle. This is the center of the circle. All points on the circle are 1 radius length away from the center. Let's use our distance formula to find the value of our radius. Distance equals the square root of the change in x squared plus the change in y squared. Let's do a little subtraction. 2, negative 2. Now let's do some exponents. 2 squared is 4. Negative 2 squared is also 4. 4 plus 4 makes 8. This is our distance. Our distance is 8. Sorry, our distance is the square root of 8. If I simplify this, it would be 2 root 2. I don't need to simplify it though, because when I plug this distance, which equals our radius of the circle, when I plug this into the formula, it gets squared. What is the square root of 8 squared? Why, it's just 8. This is the formula for our circle with the center, and it contains this point. We know that it's true because if I plug in the point 4, 3, I would get 8 as a solution. Negative 2 squared, positive 2 squared makes 8. So this concludes this next video on how to graph and how to write equations for circles.